We've been talking about systems, right? Systems is when you have two equations and they have two variables, right? And your goal is to find the x and the y that makes both equations work. The first way we looked at solving that was by finding where they cross on a graph. Not a very precise way, but it gives us a nice view of what's going on. The thing we talked about, an algebraic way to find where the solution is at, and that's substitution. We're going to learn the other one today, which is elimination, and we're also going to throw in the graphing calculator. I think today will go pretty quick, so we'll have some free time. But let's go ahead and jump in here. So how substitution worked was you replaced one of the variables with something else, right? So the goal in both substitution and elimination is to get rid of one of the variables. With substitution, you get rid of one of them by substituting it with something else. With elimination, you get rid of the other variable by canceling it out, okay? And so I'm going to provide you guys with some steps. So if you're looking at this right now and you're thinking, I don't remember how to do this, or yeah, that doesn't even look familiar to me, you might want to write the steps down. If you feel like I could do that like right now in 2 seconds, then you don't need to write the steps down. So the first thing you want to do is you want to pick out a variable that you'd like to cancel. So pick a variable that you want to cancel out. It really doesn't matter which one you choose to cancel out. So I'll go ahead and say I want to cancel out the x's. Now, some of you guys who might be a little bit sharper and you know how to do this already, you might think the y's are easier, and you're right, but just bear with me for a minute. I'm going to go ahead and pick the x's to cancel. Step 2, I'm going to go ahead and pick the x's. Like I said, I didn't say that very clearly. I'll say it again. I'm going to pick the x's to cancel. Step 2, what we're going to do is I just call this flip and distribute. Okay, what do I mean by that? Well, I'm going to take these coefficients. Remember, coefficient means the number in front of the variable. That's 5 and 1. You can take those coefficients, you're going to flip them. So put the 1 up here and the 5 down here. And then you're going to distribute them into the equation. Like that. And by doing that, you're going to create a new set of equations. They're really the same two equations. They're just rewritten a little bit differently. But what's 1 times 5? It's 5, right? And what's 5 times 1? 5. So when you do that flip and distribute, you end up creating the same number for both of those variables that you're trying to cancel. And that gets us about halfway there. So if I distribute on the top, what I would get is 5x minus 4y equals negative 12, right? We're just multiplying by 1, so nothing changes. On the bottom here, 5 times 1 would give me 5x. 5 times 2 would give me 10y. And then 5 times negative 8 would give me negative 40. And there's that. So now you guys can see the variable that I wanted to cancel now has the same number. Now remember, I want to eliminate a variable. I want to cancel it out. And so the way we're going to get that done is by making one of those 5s an opposite, like a negative 5. Okay. So now you don't always have to do this step. So I'm going to say, do we need to multiply a negative? And I'll put a question mark. Sometimes you do, sometimes you don't. If I had picked the y variables, they're already opposite signs, so I wouldn't have to do this step. But I didn't. So I picked the x's. Now, I want these to be opposites. So do I need to multiply one of them by a negative? Yes, I do. Okay, so that's my next step, is I'm going to multiply one of these equations by a negative, and does it matter which one? No, it does not. So I'm going to go ahead and multiply the top by a negative 1 then. And let's see what we get as a result of that. So now the top equation is negative 5x plus 4y equals positive 12. The bottom is going to stay the same because I'm not doing anything to that one. Hello, good morning. So, step 1, pick a variable you want to cancel. Step 2, flip and distribute the coefficients so you get the same number. Step 3, if they're not opposite signs yet, then go ahead and distribute a negative through one of them so they end up being opposite signs. Okay? So why do we want them to be opposite signs? Well, remember, we're trying to eliminate a variable. So here's where the magic happens. Step 4, we're going to combine downwards. Okay? So what's -5 and +5 make? 0. They cancel. There's that cancellation that I wanted. 4 and 10 makes 14y. Good. And then here, give me negative. Wouldn't it be 8? I don't know. Help me out. What is it? 20 what? Oh, 28. Okay, thank you. I thought you said 20. Okay, good. All right. And then from there, you guys should be able to solve. Okay, so at that point, I would just divide by 14. And once again, I'm being nice. I'm giving you nice numbers. But could this come out to be an ugly, nasty fraction? It could. So what do you think we're going to do in step 6? Just plug it in and find the x, right? All right, so that's one way, though. This is actually what's cool about the elimination method, is that if you don't like fractions, you can avoid fractions, pretty much. Since this is just a normal number, we can go ahead and just plug it in, okay? But if this was a fraction, would you really want to plug it in? Well, you could, and you should get the right answer if you do everything right. But instead of doing that, what you could do is just start over and do the whole thing again. But this time, instead of picking the x to cancel, pick the y to cancel. And you'll find the x that way. And you can avoid fractions the whole way that way. So for step 6, I'll say you can either plug and solve. Sometimes. So we can either plug and solve, or we can repeat steps 1 through 4, or I guess 5, with the other variable. So either way works. So let's go ahead and do that. I'm just going to go ahead and plug it in because it's pretty easy. I'm going to use the bottom equation just because it looks simpler. So we have x plus 2, y equals -8. And what did we say y was? -2. So we've got x minus 4 equals -8. Add the 4 on both sides. And you've got -4. So there's your two outcomes there. Okay, so that's the elimination method. Yes. Now, for those of you guys who are a little bit more comfortable with this process, you might have seen there's an easier way, but that requires comfort with this method. And it also requires some creativity, okay? So I make the long way because that way will get you through every problem. But some of you guys might have realized, what would be a much quicker and easier way to start this equation, solving this process here, Quinn? So Quinn realizes that if I just multiply the bottom equation by 2, that's going to turn this 2 here into a 4. And he can save himself a lot of trouble because they're already opposite 4s, right? So if you could see that in advance, go for it. But the steps will always get you through the process, okay? So if you're comfortable with it, then go with it. If not, then go ahead and use the steps, and then eventually maybe you'll start seeing the shortcuts as you go. All right, so there's that. Why don't I throw one at you guys here? Go ahead and do student practice number 4. Oops. I lost it. Let me bring it back. There it is. I'm here. That's wrong class. Let me do a different class. So if you didn't get it, go ahead and see what might have went wrong. So Setlali, which variable did you start by canceling? Okay, and so Setlali wants to cancel the y's out, right? So I'm gonna let you tell me then what do we do since we picked the y's? Mm-hmm. Okay. What do you guys think? We good? Yeah? Mm-hmm. So if you're using my steps, then you would have put -3. And so Setlali, you're fine. What you did was good. Okay? But I'm going to go ahead and use my steps just in case, because I came around and I only saw maybe like 2 or 3 people on this half of the class that got the right answer, so that means we need to slow down a little bit. So even though what you did was good, I'm going to stick to my steps. And so I'm going to use the same signs. But why is what Setlali did okay? Because by making this a +3 and this a -1, she's basically doing 2 steps at once, and she's going to make them opposite signs. Okay, I'm going to skip that jargon for now, though, if you're lost. So step 1 is to take the numbers, right? -1, -3, flip, and then well, let me ask. So we're gonna distribute them through. So Amanda, Deep, right? Am I saying that last name right? Or you Deep? Am I saying that last name right? Okay. All right. So what do we get if we distribute that through, Amanda? Mm-hmm. Mm-hmm. -6, right? Okay. And then how about on the bottom? Okay. Okay. +6, right? Okay, so that's what you get if you distribute those numbers all the way across, right? Okay, let's continue. John, so at this point we've picked a variable, right? Step 1. Step 2, we took those coefficients, we flipped and distributed them. What's the third step we're supposed to do?
Change the sign to the top.
Sure. Does it have to be the top one? It doesn't matter which one you do. So John told me to do the top one. So I'm going to go ahead and change the sign for the top one. And that means basically we're distributing a -1, right? So I'm going to do that. And so the top now is going to be +6x, because negative times negative is positive, -3y equals 6. And the bottom's going to stay the same. We don't want to do the bottom also, because if we did that, they won't be opposites. All right, so let's move on to Samuel. Sam, what's next? Yeah, just add straight down. So let's do that. If I add straight down here, Sam, what do I get?
4x.
Mm-hmm.
-12.
Great.
6.
How much?
4
Yeah, there you go. And then from there we solve, right? So I think if I can get you guys past those first few steps, the rest you'll get, because the rest is kind of like what we did last time. So Melanie, what's the next step? Okay, so I'll use the top. I'm going to replace x with 3. So that's going to be 6 minus y equals 2. -y equals -4, which means if I divide both sides by -1 to get rid of that negative, we end up with y equals 4. Okay? So the answer is 3 and 4. So some people, as I came around, were getting it wrong because like they just didn't even know how to start, kind of. Other people were having issues with their, signs and stuff. Really, some common mistakes that I see as I go through these with people is that on this step where you distribute it through like this, people forget to multiply the very last number. I think they feel like somehow the equal sign stops the process, but it doesn't. It goes all the way through. Another issue I see is sometimes people forget this step where you want to make sure the signs come out opposite. Like some people might have, like just from the very beginning, saw it, these were the same, the two twos, and just add straight down and cancel them out. Well, that's wrong because 2 and 2 doesn't cancel, right? So those are the most common mistakes I see. But I think we should probably practice a little bit more. Let's go ahead and do another one here. How about there we go. All right. So I'm going to let, I'll do us the honors. We're going to kind of do this one together a little bit. So I'm going to do us the honors of picking the variable to cancel. I'm going to choose to cancel out the x's, okay? So I want you guys to do the first 2 steps, okay? I've already done the first one for you. Pick the variable. Now you're going to do the second step. So go ahead. And then when you're done, check your answer with a neighbor, and I'll call on you to share out what you got. Sorry, what do I do now?
You take the first 2 numbers and you put
So what will go up here?
-3.
Cool. In here?
5.
Good. All right. Then we're going to go further than that. So Steve, what's next? Okay, so I'm going to distribute through. And did you already do that, Steve?
Yes.
Okay. Can you tell me what you got for the top one?
-15.
Mm-hmm.
+12.
Y?
Y.
Okay.
42.
Okay. And the bottom one? Okay.
-31. And 60.
16?
60.
Oh, 60. Gotcha. All right. So what do you guys think? Yeah? Negative 42? Okay. Thank you. 60 is a negative also? Okay. Anything else? Oh, yeah. I wonder, maybe that might have been my fault. Any others? So right there we see that maybe, signs could be a problem, right? We got to watch out for those signs. I think the rest looks good though. Cool. All right. I'm going to ask Andrew to tell me what's next, sir. Oh, now that's right. We want to, but we can't yet. Do you know why? They're both negative, right? So what do I need to do to fix that? Multiply by -1. Because you want to change the signs, right? If you multiply by 1, nothing's going to change. But what you want to do is change the sign, so you're going to multiply one of the equations by a -1. All right, so let's go ahead and do that. All right, so that's going to give me the following new set. The top is not changing, so I'll just rewrite that really quick. The bottom is going to become this. All right, from here, I'm going to let you guys go ahead and take it home. Go ahead and solve the problem from here, okay? And then I'll ask you what you got. So Melanie pointed out that I forgot to change these.
Does it matter which one we put negative?
No, it doesn't. But if you can't just change the 15, that's what I did, okay? You also have to change the 30 and the 60, and I didn't do that. I kept the 30 positive, and I kept the 60 negative. So the 60 is now going to be positive. The 30 is now going to be negative, so I apologize. So we'll back up a little bit and start that again. Good.
And then I added the y's, which I got 18 y.
Wouldn't it be negative?
Negative 18 y.
Go in over here.
And then I got 18.
Positive 18, good. And then
And I added 18. Or divided from that.
There you go.
And then I got 0.
18 divided by 18 is 1, but it's 1 negative, so negative. All right? Got to watch those signs, right? John's not here today. Gabriel. Now what? What would you do next? Good. So let's use the top. And we're getting 2. So x is 2 and y is negative 1. All right, so mostly just some sign issues are popping up, like, or, multiplication issues. I even made one along the way, right? So I think that's it. It's just a detail issue. So this one I walked you guys through it slowly, step by step. Why don't I give you guys one to kind of do completely on your own, and if I see something better going on this time around, we'll leave this behind. So, ready? There you go. Now, different people might have picked different variables to cancel, but let's say that I chose the y's. So if I chose the y's, 1 up here, negative 5 here, is going to give me 6x minus 5y equals 1. Bottom is going to be negative 10x minus 5y equals negative 15. But this is where people are missing it. They're adding down at this point. So if you were to combine here, you're going to get negative 4, right? And if you were to combine here, what would you get? You get negative 10. But we want them to cancel, right? So this is the step that people are forgetting. You need to change the signs of one of those equations before you combine down. So if I were you, I would circle that bad boy on your notes right now and star that, because I've seen, hey, come on, buddy. I've seen probably about almost 20% of you guys missing that step. So circle it, star it, and don't forget it. All right, so that's going to give me 6x minus 5y equals 1. We're going to have positive 10x now, positive 5y now, and positive 15, because all the signs in the bottom of the equation. Now, if I were to combine down, those go away, right? And so we have 16x equals 16, and therefore x equals 1. Okay? I'm going to go ahead and leave the rest off. You guys know what to do from there. You plug it in to get your y. You should get 1 as well. Okay? So, that's the elimination method. I'd like to show you guys the graphing method for solving a system of equations on a graphing calculator. So, go ahead and turn on your calculators and then push seconds plus 712 to clear it out. Any sort of weird stuff might be in there already. Second plus 712. All right. I'm going to go ahead and make up a system of equations for us. Now, as far as writing notes go for this, you could, but it's really tedious to turn calculator buttons, pushings into steps. So, I don't know. To me, I'm looking at you guys bringing pre-calculus as this is just exposure to the calculator. I don't really expect you to memorize a lot of the steps, just kind of getting used to it a little bit. So you don't really need to write steps down, but I do want you guys to start getting experience with it. So let's say we have y equals 5x plus 1, and let's say we have y equals y equals negative 2 plus 1. We're being asked to solve this. Okay, find the answer. Well, you could graph it and estimate where they're crossing by hands, right? But graphing calculator will do it for you as well. So why would we want to learn how to do it on graphing calculators? Well, graphing, as you guys know, is very imprecise. Graphing calculator is very precise. Another reason why is because even though with linear functions, it's actually you could probably do this pretty quickly by hand. with nonlinear equations, it's either A, I don't even know how to solve some of them by hand, or B, it just takes too much time. So linears are easy, so don't get me wrong. You could do this by hand just fine, but graphing calculator is a really cool tool to know how to use. So let's go ahead and see if we can get this idea here. So the first thing you're going to do is you're going to, wrong calculator, you're going to push the y equals button, and you're going to type both of those equations into your calculator. So I'm going to type 5x plus 1 in the top. You're going to push y equals, and then you're going to put 5x plus 1 in the first spot. And then for the other equation, you're going to put negative 2x. So push down to get to y2. And you're going to type in negative 2x plus 10. Now don't forget, there is a difference between the negative button, which is down here, and the minus button, which is up here. Excuse me. Thank you. So we want negative 2x plus 10. If you get an error message pretty soon, that's because you probably pushed the negative sign, I'm sorry, the minus sign instead of the negative. All right, then go ahead and push graph. All right, and we know that the solution to the system of equations is where those lines are crossing, right? Now our calculator can calculate that for us, and I'm going to show you guys how to do that, okay? Most of the cool stuff that your graphing calculators can do when you're in the graphing screen can be accomplished by pushing second and calc. There's a lot of cool things they can do. Second, and then this button right here that says calc or trace. The first one tells you what the y value is. So if you want to know what is y when x is a number like 3 or 4, just you push 1 and go from there. 0, that tells you where it touches the x-axis. That's actually a pretty helpful question. You remember finding roots in algebra 2. Minimums and maximums, you want to find the highest point or lowest point on your graph. That's helpful. We want number 5. We want to find where two lines are crossing. Okay, 5 or 6 and 7 are calculus, which you'll learn about later in your life. But for now, we're going to find where the lines are intersecting. So go ahead and push 5. Now your calculator is a machine, it's not a person. When we look at this, and if I were to say to you, where are these two lines crossing, you're going to point at and go right there, right? But our calculator is a machine. You need to tell the calculator what equations to look at. And you might think, well, that's obvious, it's the only ones there, but your calculator is not a person. So notice it says down here, first curve. What that means is first line. Just push enter, and then it says second curve, push enter again. You're just telling your calculator there that, yes, I want to use those two lines to find where they cross, okay? Now, the next thing you're going to do is you're going to use your arrows to scroll to where they're crossing, close as you can, and it gives you a really close guess, okay? But to get an exact answer, once that cursor is right where they're crossing, you push enter one more time, and it will calculate it as precisely as it can. So these two lines are crossing at approximately 1.3, 7.4. Okay, approximately. So that's that. All right, so let's give you another one here. This time, why don't I give you guys one that is let's make another lane. About y equals 6x minus 3 and y equals negative 5x plus 2. All right, so go ahead and see if you. So we're going to do it again, and this is going to be one of the benefits to the graphing calculator. So I'm going to ask you guys to solve this system of equations. Now these two lines are going to cross, because this is actually, what does this shape look like, you guys? Huh? The shape, like when you graph it, what does it look like? It does. It has a name. It's a parabola. So now I have a parabola, and what's going to happen is this is a straight line. They're going to cross at 2 points. I want you guys to find both. So basically, you just get to repeat the steps. But go ahead and write down both answers. So you get to do the steps twice, once for 1 point, once for another. And then I'm going to work with Brooklyn on her. Funny here. When you're done, check your answer with a neighbor, and in about another minute I'll start calling on you guys to share out your 2 points where those lines are crossing. 0.2, 1 for x, and or was y 1? Or is it 0.21 for x? Okay, and what'd you get for y? 3.9? And is that, did you guys agree? Because I didn't do it. No? Negative 2.1? Anybody, what do you guys think? That's not one of them? We'll see. Let's do another one. Malak, what was one of your points that you got? 1.9. Okay. 0.5. All right. Oh, negative 0.9. Okay, gotcha. So this is that right? Because that's one. All right. So if someone who feels like this is incorrect, what was your other point then? Anybody? Oh, we're good then? We like that point? What'd you get? Did you get this one, Melanie? Yeah. Okay, what'd you get for this one? Okay. Am I getting any agreements over there? Okay, that's fine. Turn the calculators off, please. Second, and then the on button, and then just leave them over there, and you guys can vamoose for the day. We'll see you guys mañana.